We are having this diagram that shows a binary star system consisting of two stars, each of mass 4 times 10 power 30 kilograms, separated by 2 times 10 power 11 meters. The stars rotate about the center of mass of the system. Direction of motion is inaenda hivyo na huyo anaenda hivi. Distance between them ni hiyo. You are told to copy the diagram and on your diagram label the letter L where the point where the gravitational field strength is 0. So explain why you have chosen this point. So gravitational force is usually 0 for two bodies ambazo zina the same mass. Gravitational force is usually 0 at a point where it is exactly the center between the two. So huku kutakuwa na x1 na huku x2. Okay, so lazima iwe kwenye center. Okay, lazima iwe kwenye center so that f1 iwe sawa na f2. Kumbuka hii a body at this point itakuwa ina experience f1, itakuwa ina experience f2. So if f1 is equal to f2, okay, it means g. Kumbuka nilikwambia tunapoongelea gravitational issues tunatumia kama kawaida distance is between the two bodies, lakini tunavyoongelea the circular motion tunatumia the distance between the body na center of mass. So kwa hapa tunatumia gravitational issues, so distance we are safe to assume, not to assume exactly, but to use the distance between the two bodies. But for this part A doesn't really apply kwa issues za binary star system. Hii bado ni concept ya zile za mwanzo, so it is just to apply your knowledge here kwamba these are vectors and force 1, force due to 1, assume this is a body with mass m, kwa ingekuwa na g m, kwa let us say mass ya hawa jamani m1 na m1 kwa sababu zote zina equal mass, 4 times m1 divide by x1 squared itakuwa iwe sawa na force due to x2 ambayo ni g m ya body, m ya the other distance, x2 squared. Okay, so g is common, m is common, m1 na m1 they are the same, so utabaki na 1 over x1 squared ni sawa na 1 over x2 squared. So x1 na x2 they are the same, so lazima iwe center of the cycle. And you have chosen that point because it's the point where the gravitational field or gravitational force would cancel each other. Determine the gravitational potential. Tulishasema kwamba gravitational potential is a vector. If you remember our question zile za zilizokuwa triangle, unaambiwa tafuta gravitational force at the center, nilikwambia if you are using gravitational potential is just simply the sum between the two. Gravitational potential is a vector, so the total gravitational potential is gravitational potential due to body 1 plus gravitational potential due to body 2. Yes, that's simple. And gravitational potential due to body 1 is g m over r plus h, or let us just say distance x. So the distance from where the body to where the center of the cycle is, so the body being at that point to the center of the cycle, and this should be negative, or plus negative g m. This is gravitational potential. So if x1 is equal to x2, it means this is equal to this. So basically hii ni sawa na negative 2 gm over x. So 2 is a constant, g unayo umepewa hapa, m umepewa, okay, mass of the each of them, so mass ni 4 times 10 power 30, x tumeshasema it is at the center, so ni half of the total distance between the two, kwa ni 1 times 10 power 11. Put in the numbers and you are supposed to get the answer as 5.36 negative times 10 power 9. Okay, joules. This is potential, joules per kilogram. Okay, so If we come to part B, where is our interest now for binary star systems, you are told to calculate the force on each star due to each other. Then that is just simple, because what you're supposed to do is to calculate the gravitational force, because the force due to each other is a gravitational force. So we know gravitational force is equal to G m1 m2 divided by the distance between them squared. So you have G m1 is 4 and m2 is also 4 because they are the same. Distance between them is 2 times 10 power 11 squared, and you should get your answer as 2.68 times 10 power 28 newtons. For part 2 now, calculate the linear speed of each star in the system. Tulishasema formula ya speed is given by G from here. G equal for 1 nakuwa ni G. Okay, because they have the same mass, it's just the same velocity. G m2 times r1 divided by r. So you have G 6.7, m2 is one of the masses, r1 is the half distance. Because if center of mass will be at the center, remember m1 x1 is equal to m2 x2. So if m1 and m2 is equal, x1 and x2 they are equal. Therefore half of this will be r1, and huku chini itakuwa ni the total 2 times 10 power 11. Huku juu ni half the distance, huku chini ni total. So you put in the numbers, you should get your answers 2.59 times 10 power 4 meters per second. Coming to the period, as I said hapa nyuma, kwamba the period t is given by 2 pi r1 over v1. So the period t is equal to 2 pi r1 over v1. So it's 2 pi times r1, which is the half distance, 1 times 10 power 11, and v1 is what we have got here, and we should solve and get our answer as 2.42 times 10 power 7 seconds. As simple as that. So another question, you have a binary star is formed when two stars bound by gravity move around common center of mass. Each component of binary star has a period of revolution about the center of mass equal to that amount of days. That's the period. The velocity of each component is that. Further, the orbit is nearly circular. Calculate A, separation of the two components, and B, the mass of each component. So we know that what is guiding our formula is that the period is equal to 2 pi r1 over v. Okay, so we are having the period. Okay, we are having the period, therefore r1 itakuwa ni sawasawa na 2, itakuwa ni sawasawa na v times the period, v1 times the period over 2 pi. So if we put v1, which is that, if you convert into meters per second, you get that. If you have the time period 14.4 days, if we convert to seconds, is that amount, divide by 2 pi. Okay, hapa amefanya 1 pi kwa sababu tayari amesha double. Don't worry about this. So tunapata 2 pi, we get the answer. So remember hii ilikuwa ni r1. Okay, r1, which means the one of the distances. So to get here the question is separation between the two components. So they want the distance from one to the other. So it is twice r1. So if you do times 2 here, times 2 here, you get the distance wanachouliza. And that's the reason 2 na 2 na cancel. Ndio maana kwenye solution yake hapa ili divide 2 na pi. So remember r1 naipata times 2 for this case is sawa na distance between the two. So nikuachie basi umalizie the final one, because anauliza the mass of each component, which is very easy, because we know v1 is sawa na square root ya g mass r1 is 2 over total distance. So here we have mass 2. If we make mass 2 the subject, v1 squared times r being the total distance divided by g r1. So if we get mass 2 ndo ni sawasawa na mass 1 because we say that they are both equal masses. So we solve for that and get mass 2.